Okay, with that, I believe we are at our start time. Or no, yeah, I believe we are at our start time. So we're going to get started. Welcome to Detnet Working Group at IETF 113. We are hybrid. We have a few people in the room and at least a couple of speakers who are there. And then most of us are actually remote. That includes myself, my co-chair, Janos Farkas, and our secretary, Ethan Grossman. Ethan, we appreciate you staying up late or getting up early as you're in California. Luis is our in-room coordinator. He's volunteered to help us out. Luis, thank you so much for the help. As we are at the IETF, we are governed by certain processes and policies that are covered through our note, through various BCPs, RFCs, and if you're unfamiliar with them, we suggest you go look them up. But it governs all contributions made in the IETF, whether it's in this meeting, on the list, in a document, or even hallway conversations. Similarly, we have a code of conduct that they're guidelines that basically say we should always treat each other professionally and treat each other with courtesy and respect. So we are hybrid. There is a on-site tool. It allows you to advance the slides as well as enter the queue. If you use that would be most helpful. If you don't, Luis will ask you to help manage the balance between the online and the in-room queue. And I think people are pretty good about working online nowadays since we've been doing it so long. We're using Meet Echo for the queue. We've talked about that, but we're also using it for Blue Sheets. We think it's important to sign in. It's automatic if you're remote. Please do so if you're in the room. And for note-taking, we're using our usual shared note-taking facility. In this case, it's now HedgeDoc. We've been through, this is the third iteration. Please join us on that link and help contribute. It would be we really appreciate it. And it's also very beneficial to make sure your comments are accurately captured. We have two sessions. We have the first session, the one we're in, is just for our working group. We have a joint session with PALS and MPLS, and that is on Thursday. We have a pretty packed agenda, so we're going to try to keep to the schedule. There's been a couple of updates, including who is presenting. You know what's really interesting, Janos, I just uploaded a version, but this is the old version. So somehow Meet Echo didn't pick up the latest version. So if you go to either any of the online agendas, you'll see that Scott Mansfield is going to be presenting on the second slot. And also we corrected the name. There's one other correction that's not shown on the slides that is going to be come up in a minute, and I'll talk to that. This slide is complete. I don't know what happened to this. It's complete garbage. Let's see if that's so strange. So I believe this was status and talking about documents that are moving through. I'll have to pull that up separately and remember what else is here. This is just a reminder about our disclosure process that we stop and start before each step in our process and do polls, and those polls gate moving forward. And we're all familiar with working online now, but this is just a reminder that we can host virtual interims if participants would like. All that takes is a message to the chairs and we can set something up. Okay, charter update. This is a really important conversation. We've been talking for a number of meetings about bringing in potentially new traffic treatments, including notably queuing on list. We've also, someone raised the point about we want to allow for scheduling. We agree that there are different types of traffic treatments. Our suggestion to address the list comment, which is not reflected here, but is on the online version, is to add the clause, for example, between the word including and forwarding. And so that this list is not prescriptive, and so to allow for any other changes in treatment. Do we have our AD in the room? John, are you here?
Hello.
Hi, John. For some reason I thought you were going to be in person. Maybe I just was confused, or you changed your plans.
I changed my plan. Yeah, sorry, I thought I had told you.
I'm sure you did, and I just missed it. And by the way, I was right there with you because I was originally planning to go also. What we want to do is add the words "for example" here between including and forwarding, and we just want to make sure you don't have any objection to that.
No objection at all.
Great.
I mean, I think it's implicit anyway, but it makes it clear. I think that's just fine.
Yeah, and the comment on the list, and you'll see that this is already on the list, that someone was saying that they want to talk about scheduling versus queuing, and there's a fairly fine difference there that I think most people would miss. And rather than getting into that exhaustive list, we thought that making it an example would be the best way to address it. So glad to hear you do not have any objections. We do have someone in queue. Robin?
Hello, Lu, can you hear me?
Yeah, you're a little low, but I can hear you okay.
Okay, I will try. Okay, in fact, I have a doubt because I know that the TSN and the Detnet may sharing some of this queue mechanism. I'm not sure this if we do this work in the Detnet, so I'm not sure if this work will synchronize with the IEEE and the TSN or not.
Yeah. So the way I view it is it would be a alternate queuing mechanism. We always can use different subnet layer technologies that bring in their own queuing. I think there's the sort of in theory and in practice. In theory, we want to coordinate with other SDOs and the technologies that they're defining and make sure that we're compatible with them. In practice, we need to look at the specifics of a proposal in order to address the specific question. In terms of working with TSN, we see nothing changing in terms of how we work with TSN.
Okay, thanks.
Sure. Any other questions, comments? All right, well, thank you on this point. And John, I believe, is going to bring us to the IESG immediately following this meeting, and then we'll run that process. And for the last slide, and good thing we're running ahead, is we've updated our milestones based on where we stand in the working group. We haven't updated them in quite some time. So we thought it was good to do that. Some of the changes are pretty obvious, related to OAM and our existing control plane work. Some are related to what we've just been talking about in terms of expanding the scope. And we've talked about, rather than call it out as queuing or scheduling, we just talk about data plane enhancements. And we've put in some straw man dates here for when we start adopting documents and submitting to the IESG. Keeping in mind that we are always contribution driven, so that in order to make these dates, we really need contributions from the working group. The requirements date we chose because we think we have a reasonable document, or I shouldn't say reasonable, a more consolidated document based on the discussions that we've had. And so we suspect we're pretty close there. We're going to be talking about that today. We left a little more time on the its solutions because we feel that in changing the charter today, we want to give some time for different solution documents to be submitted and to come into the working group and then be discussed. So we wanted to give a little more time on the solutions than on the requirements document. And I think those are all the points we wanted to cover. Ben?
Hi, thank you, Lo. On this page, I have two questions. The first one is, I see the IPOAM document is actually it's updated and is based on the MPS OAM document. So I'm not sure that why this document is first submitted before the other OAM documents, or is there any solution is not quite decided to be the one should be submitted? And the second one is the clarification question, because we are not quite yet sure about the enhanced what the enhanced mean in the fourth to from the fourth to the last lines about these about the enhanced Detnet data plane requirements. So I would like to first have the discussion on these two points, and then if it is possible, and then submit it to IESG before we have the consensus on this list. Thank you.
Okay, on the first point, it's pretty easy. I believe that should have just said first the OAM document. So that's a good catch. We were not trying to be specific as to which it was. So I think that's a simple mistake. And certainly a necessary correction. I did not quite follow your question or comment on the last four. I don't, Janos, did you catch it? Do you want to respond, or should we ask the statement be repeated?
Maybe I can repeat my question. The question is, I don't quite follow the meaning of the enhanced. Yeah, that specification of this word.
So we've been having discussions about large-scale requirements and then some proposed queuing mechanisms. Those have been going on for a little while in the working group, and we kept coming back to a question of whether or not defining queuing belonged in this working group or a different working group. And we've in discussions with our AD, with the transport area, there was agreement that this was something we could do inside the routing area and inside our working group. And so we have a requirements a need to define what we're going to do. That's the requirements. And then we have room for defining one or more solutions, and that's the solution document. So that's what's meant here by enhanced data plane. Now, if there's other enhancements that are needed, that's also within our within our charter. Some of those have been clearly within the charter, others have been sort of implicitly. And rather than be specific at our milestones, we're using the term enhanced DetNet data plane. Does that help?
Yeah, thank you. Much clearer. Thank you.
Okay, great. And as I mentioned, we're going to be talking about the requirements document on the agenda. It's on the agenda, and there's one solution document also on the agenda. Kwan? Kwan, do you want to say something? You're muted. Maybe we'll move to Torlis.
Hi, thank you. So that looks to me as if there would be only one document for each of these areas. Is that kind of, because I don't think we necessarily did the same thing, right? We had different IP and MPLS data plane documents. So can you try to clarify that for me?
We certainly expect one requirements document for solution. This says first solution. It doesn't say last solution. It doesn't say only solution.
Right. Well, because yeah, I mean, we can see if one requirement document makes sense, or if that would also be multiple by mean of, you know, different type of networks or use case requirements, right? So, I mean, one is always good, but I'm not sure if that's the only way to do it. Okay.
If we get, you know, as I said earlier, we're contribution driven. So if we have documents that look like they don't make sense to be merged, then certainly we can do more than one. At this time, we're not seeing that. So we do have a requirements document on the agenda. If you think that there are other use cases that are needed or not covered, perhaps bring it up then. And because then we can have it in the context of that specific document. And, you know, talking specifics is always better than talking abstract.
No, I mean, the requirement document that I'm on, I understand what it's good for and that we need it. I wouldn't claim that it necessarily covers all the possible areas where DetNet might be of interest. So that's why I think for the requirements, there might be multiple ones. And I think also as a general note, right, this is a mature working group, it's incremental work. And so then the question whether we do this type of, shall I say, 3GPP style system level documents as opposed to individual technical contributions is then a process question.
Okay, thank you. All right, do we have any other comments, questions on this? If not, we're going to move on. And
Maybe if you don't mind, Lou, just there was that broken slide. Just in one sentence, we have two documents for which publication requested. You can check it. And there is a newly adopted document, the DetNet pre-of by MPLS over UDP IP. And the OEM framework document is not on agenda, but you will hear the details soon. I'm sorry about the slide again.
all right, thank you for that. Scott, I have loaded you up. If you want to present your screen, you need to select request. Yeah, there you go.
Right, thank you. So is it?
I'm clicking grant screen and it's not giving it to you. Maybe I have to. Are you sharing or am I?
Well, I have a screen request. So,
Lou, you have to stop sharing the screen first, I think, if you are.
I'm not.
someone is.
Somebody is. I don't have control. Oh, I
because
love
that's not what I'm sharing. So let's just
all
pump
right.
this,
Let's
and
see.
I'll
can,
just advance.
I can,
I see the controls down at the bottom. I will cancel my request and just use this.
we
And
can
what I
use
will
the echo, by the
do,
way. We
yeah,
definitely.
well, what I will do is I am pasting into the chat window all of the links that I were going to talk about anyway. So first off, thanks everyone. This is Scott Mansfield. I'm representing Ericsson. Normally in this capacity, I am the IETF's ITUT liaison coordinator. So I sit in the middle between communications that go between the IETF and the ITUT. And in this case, one thing, if you check the chat window, I wanted to point out that there has been some liaison activity going on. It's also what's seen in the agenda. We received a liaison from the ITUT, question 6 in study group 13 back in July of last year. We considered it and replied to it in I don't know, November or something. You can check the liaison. And then so I've been having some conversations with the rapporteurs of Q6, and there was just a Q6 meeting last week or two. And so the chair, the rapporteurs, if you go flip to the next slide. Oh, I can flip to the next slide. I don't need to tell you that. The rapporteurs graciously created a short slide deck that provides the status of what it is that that Q613's been working on, and a pointer to how to participate and when their next meetings are. So I know I have like 8 minutes left, so I'm not going to get into the details of these slides. I wanted to provide just a snapshot of where the Q6 work now has landed post the liaison responses that we've had. If there's more that the IETF wants to say, let me know and I can say it back. If there's more that Q613 wants to say to the IETF, I also attend those meetings, and we can discuss it from that angle as well. So the two rapporteurs, Taesang from Etri is the one that put these slides together. I really appreciate the effort that he's put into this to provide a nice communication mechanism. For those that don't know the work, I'm not reading this whole slide. The thing that you need to understand is what is study group 13. The ITUT is arranged in study groups. Study group 13 is the one on next generation work. And Q6 in particular is about QoS, so quality of service and quality of experience related to networks, resource control, large scale networks, even how QoS and QoE are going to be applied to quantum key distribution networks. So this is kind of the space that they're in. I put in the chat, I put a pointer to the full terms of reference and a summary of what Q6 is doing for those that are interested. One of the fundamental documents that's driving the work moving forward in question 6, the ITUT just had a major reorganization or a major meeting that sets the plan for the next 2 years. So without going into too much detail there, I wanted to provide some information about what we see the ITUT, and in this regard, question 6 of study group 13 is going to be working on. And they created a supplement to the ITU recommendation series. And a supplement is an informational document. So this is work that was completed as part of a study, basically, in terms that most would understand. It was a study and a report has been created, and this is a supplement providing the information particular to capabilities and performance related to applications that the study group 13 thinks will be important in the year 2030. So this provides some details on how they're looking at terms like latency and jitter. I had too much caffeine. My jitter is too high right now. So so that's the basic. So, and I put a pointer to that document as well in the chat window if you wanted to see that. And then so some of the buzzwords here that that you need to understand so that we understand where the dividing line between ITUT and IETF work lies is the ITUT likes to use the term large scale networks, inter-domain networks. And so looking at use cases, frameworks, and architectures that support latency, time synchronization with or without time synchronization in large scale networks. So they're looking at it from the top down, where the IETF, well, I don't have to tell you what the IETF looks at. Everybody in this room knows what the IETF looks at it and how it looks at it from the bottom up. So this is a document that I did not provide a pointer to, but it's easy to find the numbers there, and it's a published document that provides more of the terminology that's the basis of what's going on. So they talk about without time. So yeah, just more. Like I say, I'm not going into the technical detail. I only have a couple minutes. I wanted to provide this so that if you have questions about the terminology used, how the documents are progressed, what documents are the most relevant and the most current, then you can contact me or Tae-Sing and we can open a conversation. So documents that you see in this format, so if it's like a Y dot a number, that's kind of like an RFC. If it's Y dot something like this is work in progress. And so there is now documents related to functional architecture breakdown related to the terminology talked about in Y.3113. And so this document, and this is one of the documents I believe we received and have sent comments back. And then there is LSN, large scale networks, and this is a jitter guarantee. So this is a document about, well, I mean, I don't need to re-say what it says. So it talks about the math and gives the information and definitions on how they're talking about buffering in this document. It's related to how you deal with it across a large scale network. And then there's QoS. So you'll notice requirements and frameworks. So a lot of requirements, frameworks, use cases, architectures. Those are the things that are being discussed in this group. And then so here's another document that's QoS requirements on large scale telecommunication networks. This is a key word, well, I can't highlight. So IMT 2020 networks and beyond is the terminology that the ITUT is using until the ITUR comes up with what they're going to call 5G or beyond 5G. So this is that's what that means. And then so yet another picture that shows the general view of the deterministic network, so the large-scale deterministic network framework, and provides some pointers to the terminology that's being used user-side, network-side, and multi-domain. So one of the things that I've found being a liaison officer for as long as I have is that it's important for both organizations to understand the terminology that they're using to make sure that they're talking about the same things. And then so this is an example of a use case document that's talking about particular industrial Ethernet use cases and how the work will move forward. So and this is yet another detailed, another dive deeper into the document that describes the figures a little more and provides pointers to the information about how the problem has been decomposed. And then so this is a slide that will obviously take a lot. There's a lot packed into this slide, and this is something that I encourage the people on both the IETF people and also the ITUT people that are working on these documents to look at the entire space, the entire standards area that's working on problems related to deterministic networking, quality of service, and this is a local area. So local area network. So this one is directly related to things that would happen that Detnet would care about, and also the IEEE 802.1 TSN group. So looking for where are there gaps? Are there gaps in protocol? Is it just a way of looking at it? Is it a use case problem? Is it a framework or architecture problem? And so I encourage people to look at these to make sure that the right questions are being asked. And then the last slide, and I'm looking at the elapsed time, and I'm still on time, so good. So there are meetings. These are meetings that if you want to come, you don't have to be a member of the ITUT to come to these if you're an invited expert. So you can contact me, contact the chairs, contact the ITUT, what's called the TSB, that's their steering group. If you're interested in participating in these, we can find a way to get you an account so that you can log into these meetings and provide your opinion. Another way is contact me for a liaison. So I will leave it there open for, I see no one in the queue, but I will stop talking now and let the chairs do their job here. Thank you very much for your time, and I appreciate the time. Thanks.
Thanks, Scott. Magically, I now have the ability to share again. So whatever you did gave me back control. Thank you. Okay, we are moving on. Shusan?
Can you hear me well?
Yes, and hopefully you have the buttons across the bottom.
Yes.
Great.
But could you help me to present the slide if it
I don't
possible?
have, sure, hold on one moment. I'll maybe take control back.
I can see the slide.
You want me to advance for you, is that correct?
Yes, please. Thank you.
Sure, happy to.
Thank you. Hi, this is Xue Song, and I will give a brief introduction about the status of Detnet controller plan framework, presenting other authors. Next slide, please.
I see slide 2. Is this the wrong presentation? No.
Yes, that's it. This slide provides the background and purpose of this document. This document, Detnet controller plan, is the concept of Detnet controller plan is firstly defined in RFC 8655, which is the combination of control plan and management plan. And in Detnet data plan framework document, there are also some introductions about the requirements and specifications for Detnet controller plan. And also in different Detnet data plan documents, there are some controller plan requirements. For example, for the MPS data plan documents, it mentions that there are some requirements for label distribution and label management in controller plan. And this document is intended to give a clear framework for the whole picture of Detnet controller plan, which could compile all the Detnet controller plan requirements in one place, and also give an overview of control plan architecture, which hopefully could give guidance for the following work about control plan and management plan. Next slide, please. Here is the overview of what have been defined in this document. In section 1, we have an introduction, and in section 2, we listed the primary requirements for DNet controller plan, which align with the definition of RFC 8938. Section 3 and section 4 are both about DNet control plan. In DNet 3, there are 3 types of DNet control plan architecture. The first one is a fully distributed control plan using dynamic signaling protocols. And the second is a fully centralized SDN-like control plan. And we also define a hybrid control plan, which contains both distributed protocols and centralized controlling. In section 4, DNet control plan considerations are specified in detail, respectively for different DNet mechanisms that have already been defined in DNet architecture, including explicit paths, resource reservation, and PREOF support. Also, different data plan solutions are considered, for example, MPS, IP, and also segment routing. In section 5, it is still very brief. It gives a management plan overview, which mainly includes some brief introduction about static provisioning, for example, YAM model, and also some brief introduction about Detnet OEM. Next slide, please. Pascal is in queue. Do you want to ask now or after the presentation, Pascal?
I'm okay. Hello, Shashank?
Okay, so I will.
Can you hear me okay?
Yes, yes, I can hear you.
Yes, it's about the controller plane, control plane for Detnet mechanisms. At RO, we are defining functions in the architecture which require some controller plane activity, and there was this discussion whether this should be part of the RO architecture or not, and a strong tendency to think, just like the Detnet architecture, that this belongs to the controller plane and not to the RO or the Detnet architecture. And so my question is like, would you like to include some RO consideration as part of the Detnet architecture, control plane architecture, or should we also have a RO controller plane architecture? Actually, you know, in my mind, I mean, if you could put some RO consideration there, we would be all set.
I think in the architecture document, the specifications for these functions are not so detailed, especially in the aspect of controller plan. And this document may provide some explanations and a more detailed understanding about what could be done in controller plan for these functions. So I think it can be a detailed version of the explanation, if I understand this right. But if working group have some other, yes, please.
Yeah, I think, Pascal, if you have something specific you'd like to propose, do so. And then we can judge if it belongs in this document or a raw specific document.
Oh, okay, so I'll post something on the mailing list then. And you, Lou, you know exactly what I'm talking about, right? It's all these.
Actually, I don't know. I mean, I know what's in the raw document. I'm not sure exactly what you're thinking here. So, you know, having
Okay.
the proposed words would be really helpful. Thank you.
Okay.
Carlos?
Okay.
Yeah, this is Carlos Bernardo, UC3M. I just wanted to echo what Pascal said. I think that is very relevant to have that kind of consideration. I don't really care where, but I think it will be important to agree where this work may be, or who is going to take that work, either Detnet, Pro, I mean, which a specific document. But I think that is a very useful piece of information that we need to add. Thanks.
Yes, just, oh, sorry.
No, it was too early. Please respond.
Carlos, can you go ahead? We can't hear you if you're speaking.
No, sorry. I think there was a collision. I was getting too fast to the mic. I think she wanted to respond first.
It's okay. Just as Liu has mentioned, it will be very helpful if you could put the contribution or detailed suggestion in the mailing list. And I think this document, if it is possible, we could include these different mechanisms considerations.
Right. Tolles, Eckert, Future Way. I think in Bangkok there was a quick overview also about some of the TSN protocols for their controller plane, which I forgot the name of because they're always crazy names. But that is I think a very nice hybrid one that allows you to put a central controller in or not, and makes it much more flexible. So I think it would be great to add a reference to that. I think some of the co-authors should be aware of that. I didn't see that in the list of reference technologies. Thanks.
You mean QCC? The IEEE document?
Yeah, the actual IEEE document. I was browsing through the references and I couldn't find that.
Okay, I will.
Mm-hmm.
Okay, good suggestion. I can end it in the reference part. Yes, this is the.
No,
Go ahead, please.
I think the important part is really to recognize that in the past we always had, a solution where the operator couldn't freely choose how much to centralize and how much not to, right? He either had to buy into the full distributed RSVP or the whole SDN controller. And
yeah, that's not the case in the TEAS architecture.
Exactly. But
yeah, the TEAS architecture allows the hybrid.
Yeah.
We really should move on because we're about out of time and she has a few more slides to go.
Yeah, thanks.
I will go really fast. Here is the update in this version. In the first section, we modified the management plan specification based on the discussion in the mailing list. Basically, these descriptions is coming from RFC 7426. And also in section 3, we remove some detailed descriptions of protocol extensions requirements, for example, IGP and RSVTE, and the detailed example is removed, which may depend on the implementation. And in section 4, we remove some description about the strict and loose path, which is also depends on the further implementation option. The next slide, please. Here is some issues may need further discussion in working group. The first one, which has already been discussed in mailing list and also in some previous meetings, how to deal with the relationship between this document and other RFC and working group documents. For example, the architecture document has been mentioned by Pascal, and also the data plan framework document, and also some other working group documents, for example, Detnet OEM framework. So suggestions from working group will be very helpful. In the existing status, we would like to treat this document as an elaborations or explanations of the existing specifications. And if there are some solutions has already been defined in other work, for example, Young model and OEM framework, it is mutual and it could be referred to in this document. And another question is, what is the scope of Detnet management plan? The authors cannot find a very specific definition yet. So, but there are some descriptions in RFC 8655 and RFC 8938. So in our existing understand, the management plan could include Young as configuration management and also OEM as fault and monitoring management. If people have different understanding, please also let us know. Next slide, please. So what is the next step? This document haven't include flow aggregation yet, so we will end flow aggregation, which is a very important function in Detnet in section 4, and also we ask more input from working group. It's glad to see there are some comments in our discussion. So please contribute if you think anything could be added in this document.
Okay, thank you very much for the update. Really appreciate the work and look forward to the contribution from others on the topic. And we're going to move now to OAM. Greg, you're up.
Sure. Okay. Hello, everyone. And so we'll have presentation on our work on OAM for deterministic networks using with MPLS data plane, and it will follow with the IP data plane. Next slide, please.
The controls.
I have control. Yes, it's a yeah. Okay, it's a fading colors. Thank you. Okay, so this is update. We welcome our co-authors Janusz and Balázs, and by this meeting we updated Detnet ACH definition and provided specifics of flags filled and related filled in related IANA registry. So Detnet ACH is now different from where we started with their more like based on pseudo-wire ACH. It has a new version number, so it will be differentiated, easy to differentiate from the pseudo-wire ACH. It includes its own sequence number, channel type, and also their second long 4-byte long word carries the node ID, level, flags, and session identifier. Any questions? Okay, now the flags field.
How much have you been coordinating with the joint work that's going on with PALS and MPLS?
Yes, it's a good question. So we are closely monitoring, following, and participating in the discussions of open design team. The fact that we are following on the pseudo-wire architecture where their control word or ACH are expected to immediately follow the bottom of the stack label. So we are in a different position. So we are in this sort of a protected space that enhanced MPLS architecture that open design team is working should not affect.
Great, thank you. That was sort of a planted question to see if we would get any comments from others who are participating. Looks like they're happy, so we can move on.
Yes, thank you. And I appreciate this opportunity to clarify how Detnet with MPLS is related to work of enhancing MPLS architecture. Okay, so now, for now, their flags field is composed of 5 bits field. Each flag field is 1 bit long. And for now, in this document, each of them is unused. And that is reflected in the proposed IANA registry that is requested to create a new Detnet MPLS OEM flags registry and do assignment as in this copy of the table. So that's what now in the draft. Any specific questions about flags or the registry? Okay, thank you. So for next steps, we always appreciate the comments, welcome suggestions. And we are planning to work on this document and would probably ask the working group to consider a working group last call before the next meeting. Okay, comments, questions? Okay, okay, yes, Fang.
Hello, Greg. Thank you for the presentation. I have a question for the encoding or encapsulation of this Detnet OEM format. I see there is a node ID and session ID. I think I remembered. But before we define this encoding of OEM packets, do you think that we should have a general consensus on the OEM mechanisms? Because I see there is a new encoding, so that's it's different from what we have in previous OEM mechanisms. So I don't know if we should first discuss the mechanism, how we use it, and then we decide how to encode it. I think
Okay,
that is
yes, very good question. So as for encoding, we are not envisioned that, okay, we propose to reuse all the encodings that are we are familiar with in pseudowire encapsulation. So that there are IPv4, IPv6 channel types for ACH, and that means that Detnet ACH can be followed immediately by IP encapsulated OEM. For example, it could be LSP ping, it could be ICMP, it could be BFD control message. In case of LSP ping and BFD control message with IP encapsulation, so that they can use loopback address, whether it's 127/8 range or as prescribed in 5884, for example, their range for IPv6. Or it can use non-IP encapsulation of BFD. So then BFD control message will follow, for example, DACH immediately. And then it can use a TLV for identifying their source. Does that answer a question?
Yeah, I understand it. I agree with what you have said. But for the new defined, like the session ID, how we use it, actually we don't know this. So
Oh,
yeah,
yes.
Yeah,
Actually, that's a very good point, and we welcome suggestions and proposals. We were thinking that in this document, we do not go into the how these fields are used. So we just define them, and their use will be defined in further documents. Because, for example, as you noticed, flags, yes, we can define some flags or all flags, but that might take time. So we found that it might be more practical to define these flags now and then let further documents to define and allocate particular flags, because for now that's like unused. And I can point that it's the approach that's been used, for example, in SRH extension header in IPv6, where the SRH defined flags in its base RFC. And then now, for example, the proposal on OEM in SRv6 defines one of the flag fields as OEM field.
Okay, thank you. Thank you for the reply. And I think I won't use too much time here to waste for the the time for the other presentations. But let's continue the discussion on the mailing list. I just want to say it's not quite ready for the working group last call. Yeah, thank you.
Of course, let's continue discussion on the mailing list, and thank you for your question. Okay, so now I will try to return some time because this will be another short presentation. I hope shorter than a lot of time. Okay, so let's recap what we have proposed for active IP or Detnet IP OEM using Detnet in UDP. And then I will be looking at how active OEM can realize Detnet service sublayer in a Detnet IP environment. So with the Detnet in UDP encapsulation, we have to map the active OEM flow with their monitored Detnet flow, so that to ensure their fate sharing. And that's because in IP, we have to work with their several active OEM protocols. For example, it's ICMP, or it's a BFD, or it's a performance measurement, whether it's a TWAMP or STAMP. And they usually use UDP destination port or transport encapsulation that is distinct from the Detnet flow. Any questions? Okay, now to fun part. Realizing Detnet service sublayer for the Detnet flow, it uses MPLS over UDP. And that's well-known and established technique. For Detnet OEM, in this case, it also must use MPLS over UDP, and then it's naturally is sharing fate with the Detnet flow because it can use the same IP, the same UDP, and the same MPLS encapsulation, and then identify their active OEM just using DACH. And the next slide illustrates that very nicely. So as you can see, all the transport encapsulation for Detnet flow and active OEM are identical, and the differentiation only in using Detnet control word for the Detnet flow or Detnet ACH for active OEM. And your comments, suggestions? Yes, Lou.
So, we've talked about this in the past. Having a solution that leverages MPLS over IP is really very straightforward and makes a lot of sense. But we also need a solution that works when we're not running an MPLS data plane and we have no MPLS at all. So really needs a solution that works for native IP. And, I think that's I think there's room in this document or maybe another document to cover that, but it's really important.
Yes, I agree. Okay, let me bring it a little bit back here. So we are following the data plane encapsulation. So Detnet in UDP does not realize Detnet service sublayer. So it
Right,
only a
and there's
tunnel.
going back to a hallway conversation you and I had walking on the streets of Singapore, actually. A Detnet flow, or whether it's a fully distinguished or an aggregate flow, can operate just at the IP header levels. Currently, we have it, the 6 tuple, and it's important to have a solution that also works with that. And as I read this, this doesn't work with any 6 tuple flow. It only works with UDP, and that's
yes.
UDP.
With 6 tuple 4. Okay, then it could be UDP and UDP.
No. Why not? Why do you have to do encapsulation? You can just do fate sharing with having an aggregate flow. I suggest we talk more about this offline.
Okay.
It'll be on me to give you those comments. But the point is, I think we have to cover the full 6 tuple native IP flow as well in this document, and I'm saying that as contributor.
Okay.
Thank you.
Okay, Pascal, please.
Reference, but Greg, if you want to work together, we can effectively see how we can transport OEM information natively in IPv6 using basically what we are trying with the Detnet options in my presentation a bit later in this meeting. So the idea is pretty much like your other slide. Can you go back one slide? It's going to be important. Can you go back the other slide? Yes, exactly. So in this slide, we see that the OEM is wrapped up, in this case MPLS, right? It's wrapped up on the same envelope as the data, and this envelope is actually a network construct which indicates the treatment of the packets. So MPLS is really pointing on the path and on the treatment. And inside that signaling, we signal OEM. And so basically the goal would be to do the exact same thing for IP, is have a network layer construct which signals the path, the treatment, and then inside that thing, place one or multiple application flows and OEM. So yes, basically realizing this, but over IP without the UDP, just the 2 inner tunnels.
That's very interesting. So I'm looking forward to your presentation. Thank you for the comment. Okay, so I think that well, we'll have several discussions on the mailing list from these presentations, and I appreciate your comments and interest. And yes, let's continue work. Thank you.
Okay, so this presentation is about the packet ordering function. Together with my co-authors Tobias Herr, Stefan Kerrer, János Farkas, and myself. Do I have control, or you will switch to the next slide? Oh yeah, I have.
You should have control.
Yep.
Otherwise,
Excellent. It's
sorry.
Okay. So the actual status is version 2 of this draft. This is describing algorithms which can be used for packet ordering function in the Detnet service sublayer. So the packet ordering function is needed because replication and elimination by the characteristics, they may result in out of order packet delivery, and that can be confusing for some time sensitive applications. Version 2 was presented in the last IETF. There were also discussion during the meeting after that in Guttertown and also on the mailing list. And those discussions were about the possible delay variation, which is caused by the packet ordering function. The conclusion of the discussion was that in Detnet, we are building functions in order to achieve a given target, a given end-to-end deterministic characteristics. And we are intending to use and define building blocks in order to achieve these end-to-end characteristics. And in version 2, it is already stated that it is out of scope how to eliminate the delay variation caused by the packet ordering. The text already contains some hints how to do that. You can use, for example, digital buffer or a flow regulator, like a shaping function after the POF functionality. But the draft is focusing exclusively only on the algorithms which are ensuring the packet ordering functions. So this is why there was no update in the draft. And this discussion resulted in that if you intend to change the delay variation or fine-tune the delay variation, then you will need additional functions after the POF functionality. So the content of the draft is pretty stable. We have received many good comments for version 1, and they were already included in version 2, which is now a stable version from the POF algorithms perspective. So therefore, we think that the document is stable enough, and we are looking for having a version adoption for this document. Thank you. Any questions, comments? Yes, Torres, please.
Well, at least you don't have to stand in line here the whole time, but you need to click before you go to the microphone. No, thanks for the work. I think the difficult part that hasn't been approached now is that, or at least what I would love to see ultimately is, I guess, a normative standard Yang document that exposes the parameters of whatever POF is being done, so that when we go into deployments, the Yang model gives us the knowledge that we can actually build a controller plane that has the necessary information. And obviously, such a Yang model would have to be built from what we're describing here more informationally, and I'm not sure what the processes we're doing, and if we even agree on that goal to getting a normative Yang model to expose all the relevant parameters.
I think it would be interesting to have such a Yang model, and not only for the POF, but for all the other service sublayer and forwarding sublayer functions as well. Right. So I think that is definitely something that is needed. I agree with that. From this document perspective, we have defined the configuration parameters which are configured for the POF algorithms described in this document. So the parameters are defined, and for the Yang model, I think we are missing not only for POF but for other functions as well, extension to the Yang model that we already have for that.
Yeah, and hopefully, you know, a Yang model, as difficult as Yang is, to just, I mean, it still seems to be the best way for us to standardize the data model is, you know, I mean, that, I guess, yeah. Yeah, there's some, yeah, thank you. I think we're running out of time.
Yeah, I'll just remind you both, we're contribution driven. So a draft that augments our existing Yang model or even a completely independent one, if appropriate, is always welcome. Pascal?
And me the presentation for the slides. Oh, I think I have them. Okay, very neat. Many thanks, Lou. So yeah, this is basically a continuation of the discussion we just had on Greg's slide about being able to transport multiple types of flow using a network construct that is independent of the application construct. So the application construct with the socket is expressed by the 5-6 tuples. It retells you what the application flow is, and that's what our architecture says. On the other hand, if we want to be able to transport multiple objects, including OAM and aggregated flows, it might be ideal, just like we did for MPLS, to have a network construct that expresses what the network should be doing for this collection of packets, regardless of the flows or of the OAM data being transported. And effectively, IPv6 provide that sort of constructs. It's done through extension headers like the hop by hop, the destination information object, and the source routing header. So depending on what you really want to do, I mean, one or the other of those extension headers is ideal. For instance, in the art of repo, and now for VTN IDs that was discussed at 6man this morning, the hop by hop header is being used to express a logical topology. I see that Craig is speaking already. Greg, do you want me to finish this slide and then you speak, or do you want to speak now?
I want to be first in the queue.
Okay. Okay, so just let me do this slide and then I will point to you. So basically, I was saying that the concept of expressing a logical topology using a hop-by-hop header has already some history at the IETF. And there is effectively, for virtual transport network, for instance, a draft, which is workgroup document at 6man, which encodes a VTN ID into hop-by-hop header. In the same fashion, REPL has the REPL option, which is also encoded in a hop-by-hop header to express what we call an instance, which is also a virtual topology. So if we consider that a path, which is a complex beast between an ingress and an egress, is a topology, is a logical topology, it just makes sense to do what the others do and express it as a hop-by-hop header. In particular, because we want that every node on the path has the forwarding sublayer operation. So it makes full sense to encode it in a hop-by-hop header. The cool thing about a hop-by-hop header is that it's completely near it's the first thing after the IPv6 header. So if you need a harder implementation, and that cannot go beyond, say, 64 or 128 bytes, then having the hop-by-hop header immediately after the IPv6 header allows you to process it in hardware. So that's pretty important for forwarding. Now, for the service sublayer, not every hop necessarily processes it. It's only the relays. So another way of encoding that could be substitutable is using a SRH, which source route header, basically, which indicates what the relays are, and the destination option that provides the service sublayer information just before the SRH. And that's really how it's going to be processed by the intermediate hops, which are signaled in the SRH. So basically, all I was saying is, instead of looking at the application signaling, which is a 5-tuple one, which can be far in the packet, it might make a lot more sense to wrap the things we want to process the same way, which share a common fate, in a layer 3 signaling. And the extension header are fine for that. And Greg, there we go. Greg?
Yes. Yeah, now it's off. Okay, unmuted. Thank you for this presentation, for the putting it so clearly together. I've been following discussion in 6man on a hop-by-hop extension header. So my understanding is that, yes, there is a requirement, or let's say probably expectation, that each node will decide on its own whether it can capable of processing received hop-by-hop extension header at line rate. And if it's not, then it will just forward it. So as a result, or as I understand it, the processing of hop-by-hop extension header is not guaranteed unless we tighten our unless we tighten our requirements for the domain, for the nodes that are in domain and in encapsulations, so that we can ensure that in Detnet IP domain with IPv6 data plane, the processing of Detnet hub-by-hub extension or hub-by-hub headers that used by Detnet is guaranteed.
Yeah, I mean, that's the most of the problem you're talking about is because the IPv6 hub-by-hub document is for the global internet. As soon as you're in a local domain, which is by charter Detnet, this problem goes away. I mean, if you want to deploy Detnet, you will have to have Detnet support on every router. And you will deploy routers which support whatever signaling you place in for Detnet. So the point is not the capability of the routers, because for a limited domain, you will effectively have the right routers, whether it's over UDP or if it's right after the IPv6 header. But you might have trouble implementing it on other merchant silicon if the Detnet signaling is beyond the first 64 bytes. And that will be a problem, because if you are above UDP, basically, for some hardware platforms, whereas placing it in a hub-by-hub gives you a much better guarantee that you can find more routers which are capable of processing it. So yes, hub-by-hub is not guaranteed, but that's in the internet at large. In your limited domain, yes, you will deploy the routers which support whatever you want to do. And hub-by-hub is actually easier than above UDP.
Yes, what I think that, and that probably we'll discuss it on the mailing list and in following discussions, is the impact or interworking with this mechanism and other extension headers, for example, SRH. But
yeah,
yes, let's move it to the mailing list.
The draft has text and yeah.
Watch the time.
Okay, so I will skip the next slide. It pretty much shows that the extension, the hub-by-hub, is right after the IPv6 header, whereas the transport can be far away depending on how many other headers you have, which can be a problem in some IP networks where the hardware cannot go too deep inside the packet. So the requirements are twofold. We have got all the redundancy in the service sublayer, and we've got what I was talking about, the envelope of your multiple application flows plus OAM. And so that's why we have two different types of options proposed in the document. In the interest of time, I'm moving on. So yeah, we insist in the draft, and I guess the raw architecture insists on that as well. Not to confuse what we call the water and what we call the pipe. The water is the application flows, and there is signaling for that, which is really under the control of the application. In the network, we don't control the tagging of the ports and the upper layer protocol that signal the application flow. So using them inside the network is actually sometimes complicated. Whereas having like MPLS, our own tag in the packets, which we can use to find our state and our operation, is a lot easier. So that's really a reason why we want to place it in a hub-by-hub as opposed to leveraging the 5-tuple. The other problem with the 5-tuple is you would need a 5-tuple inside the 5-tuple if you want to merge OAM and the application flows. Here we are a lot more economical because we just place a tag which basically indicates the virtual topology that you want to follow. And yes, current version is 7. So we added effectively to Greg's point some text regarding the various encapsulation and the placement of the headers. So Greg, if you look at the new text and the submission by Fan, and Fan joined as co-author. And then we in section 7 we enrich the application section. So we position better versus the Detnet architecture, which shows it's a good fit. And it's time to stop. But basically, many thanks to Torles and Brian for their comments. And we'll publish very soon the new version which incorporates that. and I'm pretty much done. If we have any question. Oh, and thanks to Tiara as
We
well.
don't really have time, unfortunately, for questions. I think this is really interesting work. We do have room in our charter for more enhanced, or actually not even more enhanced. This was just a more sophisticated data plane, IP data plane support. We always called the original 5-tuple the simplified approach. So this certainly fits in. Whether or not use hop by hop or maybe even flow ID, I know that's not that's being frowned upon, but it would be good to talk over with.
You mean flow label?
Flow label.
When you said flow ID, you mean flow label.
I meant flow
yeah.
label. Thank you.
Yeah, the problem with flow label and 5-tuple, it's the endpoint decision. So it's for one flow. For the next flow that wants to share fate, well, I don't know, share the same fate, you have a problem of signaling. We should leave the endpoint application level stuff to the endpoints and do our own construct for the network, just like MPLS does. It makes a lot more sense.
Sure, but it would be good to socialize the idea also in 6-man.
Oh yeah. And the VTN ID is being socialized. And this morning I asked a question effectively on because we are doing the same thing in role in VT. Well, you know what T's right.
Yeah, that's great.
And
we should move on, Pascal. We should move on. Thank you very much. Appreciate it. And for the next presenter, I think you're squeezed down to 8 minutes. And
okay.
You should. I'm handing you slide control now.
Okay. This is Peng Liu from China Mobile, and it is a requirement of large-scale deterministic network. Next slide, please. Okay, next slide.
You have control on the bottom. You should be able to select just underneath the slide.
Okay. Yeah, I see it. Yeah.
Okay, thank you. Oh.
Okay. First is recap, but I can't see it clearly.
Yeah, I can't either. I guess I can try to.
Is there any problem? Yes, but I could say it. Yeah. The recap and motivation. It was presented first in the interim without a draft, but absorbed some good points from the earlier draft. And since there was positive feedback, we submit and presented the new draft based on the slides in last meeting. And before this meeting, we merged another requirement draft according to Chair's suggestion and addressed the comments in the last meeting and offline. So the motivation of the document is to point out the different aspects in large-scale deterministic networking, such as queue mechanisms, and also has a little others. Okay. Oh, good. And some facts are that the deterministic network prototypes and trials have been performed based on the proprietary mechanisms in large-scale network, and the experience from them were used as input to this document. Next slide. Okay, I control by myself, so forget it. And from the last meeting, got some comments, and those are other updates. We merged another requirement draft as 2 technical requirements showed in the next 2 slides, and add a trial example of an electronics and telecommunications research institute, and moved the example of the trial to appendix for reference based on the contribution added Taurus, Chen, and Zheng Dong as co-authors, and also removes these 2 based on the comments. So this is the first added requirement support configuration of multiple queuing mechanisms. There will be the diversified deterministic traffic flow forwarded based on different queuing mechanisms in some network device of large-scale network. For instance, the network aggregation device may need to support both TS and ATS. So the network device should support multiple queuing parameters. And accordingly, the unified or simplified configuration and management are expected to be supported. So for the distributed and centralized scenarios, some simple requirements for the advertising or some resource topology pool when needed. And this is second added requirement is to support queuing mechanisms which over cross multi-domains. It may cross multi-domains and adopt a variety of different queuing mechanisms within each domain. So it is required to support the inter-domain deterministic mechanisms at the inter-domain boundary nodes, such as a priority redefinition and rescheduling of queues. Moreover, changing from the one queuing mechanism to another may generate additional end-to-end latency or jitter. So collaboration mechanisms across multi-domains must be considered, such as the increasing buffer or inter-domain device to provide enough adjustment space for the flow to across different queuing mechanisms. And this is the appendix about the trials. Here's a new the remote industrial Internet of Things service of the ETI, and it through 3 different operators network and demonstrates the real time with a smart factory, and the low latency and boundary jitter showed here. So some takeaway is that strong motivations and demand on the enhancement to support large-scale Detnet and the proprietary mechanisms coexist with standard technology in trials. So there must be some enhancement to support it. And then here's the overall technique requirements. And first is tolerated time synchronization. Considering in the large-scale network, there must be some device can support the synchronization. And the second one is support the large-scale single hop propagation latency. Brings long distance latency to support it. And the third one is accommodate the higher link speed. And the fourth is be scalable to numerous network devices and massive traffic flows. And the fifth is tolerate failures of links or nodes and topology changes, because those will bring maybe second levels latency, additional latency, yes. And 6 and 7 was introduced before. So next is that considering the recharter of the WG, we extract some potential data plan implications from the requirements. Okay, first is a IPv6 extended header-based enhancement to support the native IPv6 network, and currently there is no change of the extension headers. And the second is the redundancy-related files for the pre-auth. The PS data plan support while the native IPv6 data plan doesn't have the files. Okay, third one is for the aggregation flow identification. The IPv6 aggregate flow identification is supported by 5 or 6 turbo IP prefix or wildcards. It is okay when the network is small, but in large scale, the number of individual flow is large that may randomly join and leave the aggregated flow. So in some cases, the flow can't be identified by the prefix or wildcards. Finally, is some consideration about the queuing-related information to be considered, such as cycle identification or the time step or time information like fields. So next is since the draft absorbed the earlier draft, merge another requirement draft and got enough discussion and notification online and offline, we'd like to request for an adoption call as a start point for the enhanced requirements document. Thanks, and any comments?
Unfortunately, we don't have time for more discussion. So others, it would be good to, if you have comments, take it to the list. I'm particularly interested in if we're missing requirements. we showed on the milestones that we would like to get a document to on enhanced data plane. This seems to be the one that is the likely candidate. So we'd like to see some more discussion and probably poll for adoption as soon as next month. So thank you very much for this contribution.
Okay, thank you.
Next up, I believe, is Torlis. Oops, I hit the wrong one. Torlis, you're in the room. Do you want someone else to advance for you? Or do you have the app? I'll give it to maybe Luis, if you don't mind advancing. All right,
The sound is so echoey, it's really hard to understand. Next slide, or first slide?
Sorry, I need to manage this problem. Right?
All right, so wanted to re-summarize the high level, what we're trying to achieve here. Next slide. So we think we need, according to the previous presentation, a standardized bounded latency solution for large-scale high-speed networks. And if we look at what we are kind of under the hood thinking of being available today, that has been proven, I think we have the guaranteed services from RSC 2212 and TSN ATS as the two mechanisms that I think people who have worked in TSN know. We don't have the Yang models. There is a proposal for RSVP for that, but if we look at both of these queuing mechanisms, they really have three core issues, right? So one is the insufficiency for applications because of the fact that they have the maximum jitter because it's load dependent. And that may lead to a lot more complicated applications with clock synchronization on small IoT endpoints as opposed to only in the network. The second one is the an expensive scalability because of the per-hop state required in service provider networks. And then, of course, kind of like as a follow-up, the non-applicability to current and future forwarding planes that can operate stateless, like SR-MPLS, SRv6, and for multicast beer or other similar upcoming ones. So those are the three big limitations of these well-known queuing mechanism. Next slide. So, and then there is TSN cyclic queuing and forwarding, which is another TSN proven standardized solution, and that solves problem 1 and 2, but it doesn't really work for high speed or wide area networks because the cycles on adjacent nodes need to be matched by the synchronized clock. So that means that they don't support arbitrary length with latency and jitter, and require an extremely high clock accuracy linear to the speed of the network. So far, to the best of my knowledge, this has been proven to only work up to 10 gigabit per second. So that brings us to the wrong indented tech cyclic and queuing forwarding that we're proposing, which is really an enhanced version of the cyclic and queuing from TSN. And it solves that high-speed WAN link issues by carrying the cycle identifier not just internally in the node and updated by the clock, but it's in the packet, and that basically makes it easy to support arbitrary latency links, even with jitter. And there are high-speed implementations as proof of concept, pre-standard, obviously with equal to or larger than 100 gigabit interfaces, and deployed for testing in a 2,000-mile long network in China. Next slide. So we talked about this on the last session. It's also in the draft. It kind of explains how the more cycles you configure into the solution, the more leniency you have against latency variation or time interval errors in your clock synchronization protocol. So basically, it's also flexible insofar as that it can, by mean of configuration of more than 3 cycles, accommodate for more variances. Next slide. So right, so the draft that we have was the attempt to try to get two things out of it, right? So one is to propose a standard TCQF mechanism with a per hop state machinery that could support any type of tagging. Even, different hops along the network could use different tagging, like one uses IP, the other MPLS, not that that's realistic in current networks. And then really only standardize here the one tagging that we know we can do without expanding any forwarding plane, but just using the one forwarding plane we already have, almost everything else, which is the MPLS forwarding plane with the traffic class field, which just relies on RFC 3270. And that's the easiest to operationalize thing. And this is what this is the draft we want to ask Detnet to adopt as a working group draft. Next slide. And so then obviously there is the question of what's the adjacent work, right? So obviously we want the Yang model to specify the configurability. There is the open question of the ingress policing into the network, which I think is a general purpose issue. In the case of this queuing, it's not only the policing, but there is a tagging with the appropriate cycle added to it as an added requirement. But I think it could go either into this document as a section that hasn't been written yet, or it could be a separate document. And then, of course, we could equally then, once we agree in Detnet that this is a scheduling queuing mechanism that we do want to support, I think much more easily go to other working groups accordingly, write the tagging for others, one like DSCP, probably with TSVWG. And then, of course, the whole question of how do we do it with SRv6, where we may want to have a source routing header that per hop indicates the tag, something I think where even an olden draft existed, right? But to me, that's adjacent work. Just bring it up to the point here that it is relevant to, the adoption call for this draft, which we would like to have. And I think that's it. Next slide. I think that, yep. Thank you very much.
Thank you, Carlos, for this work. As we mentioned, we're going to give some time for other solutions to be proposed before considering adoption. Probably around the next IETF is when we'll look to do adoption of solutions for treatment enhancements. Kwan?
But of course, anything that people would like to see improved on the document, right, as early as possible.
No, Lou, do you hear me?
Yes, Torlis was just making a comment. If you could let him just finish his comment and then go. Torlis, do you want to finish your comment?
No, that was it, right? So thanks.
Okay, thanks. Kwan, go ahead.
Okay, thank you, Lou. My question is not only for Torres, but also for Charles. Do we plan to adopt one data plane solution for a queuing mechanism, or it may be better to try to define a generic data plane solution to cover all kinds of queuing mechanisms? Because this draft has mentioned IPv6, MPLS, and SRv6 for the TCQF, and maybe we have other queuing mechanisms. Then we will have many data plane solutions.
So if my answer to that would be that I would hope that the Detnet working group has space for multiple, bounded latency queuing or scheduling mechanism, as we want to call them. I was just thinking that this one would be the one that would be most easy to justify as standardizing first, because we've got the deployment experience. It's derived from something that has even more deployment experience with TSN. So, I mean, we have nice research work for something that we, think might long-term be even better, but where, high-speed hardware implementation experience is missing. So, and it maybe the same would be probably true for other cool ideas that are being brought to Detnet. So maybe we should look at, the realistic timeline of adoption in actual high-speed networks as a factor to guide us, but not prohibit something to happen.
Yeah, and Kwan, I think you're actually getting at the point that there's a difference between queuing and marking, and marking tends to be data plane specific, and we would expect that to be in individual documents. The base queuing mechanism could be in a shared document or even show up in one document, one data plane document first, and then be referenced by subsequent ones. We do see that there's definitely different data planes we're managing, and we talked about there being a first document for a solution, and that we may entertain multiple. But as usual, as I said multiple times, we're contribution driven. So if you have an alternative, it'd be really interesting to see a contribution on that. And there is time before we talk about adoption on this one, specifically to allow for more documents to be published. And with that, any subsequent discussion has to go to the list, and we need to move on to the next presentations, or they won't have any time. So let's be fair to them. No, let's be fair to the others, please, and move on. So I think, I'm not sure who's presenting next. But
I'm sorry, just that somebody opened the doors again in the room, and
I
can't hear you because there is all this noise coming in from the outside. So it's really
okay, I'm sorry, I can't. Sorry about that. So you should be able to present. Shafu? We don't hear you. So we're going to skip this presentation and come back to the person at the end. Hopefully they can fix their mic problems between now and then. My apologies, but we can't hear you. So we're going to the one-way delay measurement.
Hi, Chair. Can you hear me?
Yes, you sound good, and you should have.
Yeah, thank you. Yeah, thank you. Okay, next page, please. And from China Mobile. Yeah.
You have controls at the bottom of your screen.
Okay, thank you very much. Sorry. So today I'm gonna give a presentation about my draft on the reference delay-based mechanism about the one-way delay measurement. So one-way delay measurement is very important, and is a great performance indicator for SLA guarantee, and especially for some scenarios in 5G network. So OWD, the one-way delay measurement, is not a novel research. Many studies has been done in years before, and especially some RFCs also been published in IP performance measurement group. But our proposal is quite different, and so it's based on a prerequisite about the Detnet. So that's why we want to present this in Detnet group. So you can see that the current deployment of the one-way delay measurement deployment is usually based on some clock synchronization mechanism such as PDP or GPS, but the deployment cost is quite high. Or if you want to do some approximate measurement, you usually use RTT, half of the RTT, but it's not accurate for the some scenarios. So our proposal introduces a new method to accurately measure end-to-end one-way delay, so without using the clock synchronization, and it only uses a reference delay based on the deterministic path inside the network, and the network latency is quite is guaranteed and has very low jitter. So as you can see in the typical network topology, we deploy between the sender and the receiver, they have a clock offset. We need to first send a reference packet from the sender to the receiver, and then following we want to measure the target packet and between the sender and the receiver. So there is a clock offset between the sender and the receiver. And for the reference packet, it is sent through deterministic path, so that it means that the delay is known before. Is based on the Detnet, and the target packet is what we want to measure. So we just need to record the send time at the reference packet and target packet, and then the similar and the arrival time and the timestamp of the both of the packets. So our calculation method is shown here. It only has two equations. We know that the reference delay can be calculated inside the at the very beginning at the very beginning, and it won't be changed during the measurement. And the offset, the offset 1 and offset 2 can be seen as equal when we send the reference packet and target packets. The interval is quite short, so we can assume that both offsets is the same. So we can use equation 1 and equation 2 to derive to the third equation, where the target delay between the sender and the receiver is determined by the 4 timestamps recorded at the both end and the delay reference delay. So all of the 5 values are known. So here the target delay can be calculated. So our method, here are some measurement procedures. I won't explain it in detail. You can see in my draft. And the timestamp can be also encapsulated in normal format, and you can insert it inside the TCP header between the payload and TCP header. And also, so I want to sum up with my proposal. So our mechanism has no need to deploy time synchronization. So that's the biggest, the vantage point of our proposal. Yeah. So you can largely reduce deployment cost of accurate one-way delay measurement compared to the current or state-of-the-art measurement mechanism. So it also has no impact on intermediate network devices. It only you don't need to care about the intermediate network path. Just you need to know that you have a deterministic path between the two ends, and the target packets might not send through the deterministic path. It can be sent through some different path. Between the sender and the receiver. So you can use the delay. Reference delay to calculate the measurement path and the target path. So yeah, that's my major concern to propose it in Detnet. Thank you. So if you are interested in my my proposal, you can talk to me. Yeah. Well, also you are welcome to join to our work. So any questions? I see that some friends are raising their hands in the queue. So please,
let's try to be very brief on the questions and the responses, and then continue on the list. Greg?
Thank you. I just want to note that clock synchronization helps with their or mitigate their instability of the timers. So without clock synchronization, the network, the timers might fluctuate differently and skew. So it not be a constant difference between clocks on different nodes. but it will be floating, so that much more challenging and difficult. Thank you.
I
Yeah,
think
thanks.
I think in fairness to the others, we have to take the questions on the list and give them an opportunity to talk in the remaining 10 minutes, if that's okay, to Dean and Dan and Bing Yang.
Yeah, sure. We can talk via chat box, or you can send me emails. Yeah, thank you.
Okay, we're going to try again. If Xiaopu, if you could say something. He said that his local test passed, but we are still not hearing you.
Hello?
Yes, we hear you. Excellent. You have 5 minutes.
So I will take this representation quickly. We introduce a specific solution that about Detnet-based forwarding. Next, thank you.
You have controls at the bottom of your screen.
Oh, thank you. So the motivations, Detnet architecture defines cruise goals. We know that are bounded delegate, bounded packet loss ratio, bounded out of order delivery, and use the resource reservation, explicit routing, and service protection to achieve these goals. Resource reservation is the basis of ensuring bounded delegate and ultimately depends on the queue mechanism of the forwarding plane. The widely used priority-based queue scheme may give better average latency, but with worst-case latency. Thus, an enhancement scheme of PQ is proposed. Okay. This page is about deadline queues. Deadline queues are variants of PQ and also based on priority scheduling. There are several attributes of the deadline queues. All deadline queues have TDL attributes staggered from each other, decreasing with the passage of time. And the deadline queue with TDL 0 has the highest priority. Heighten the existing strict priorities. Subsequently, 0 will be reversed to the maximum initial value. The deadline queue with TDL non-zero has a normal priority if in-time policy and prohibition priority if on-time policy. The former can be involved in scheduling while the latter cannot. The following figure shows a simple example of deadline queue that it contains 4 deadline queue. Each with series TDL attributes 0, 1, 2, 3. After the time, the passage of time, for example, 1 microseconds, the TDL attribute will be changed. So next. Okay. So this page is about how to put packets to the deadline queues. It mainly include 2 steps. First, get the deadline information of the packet, including the planned deadline. The planned deadline can be computed by end-to-end delay minus the cumulative link delay. Then the result is divided by the hop count. There's a spelling mistake. It's not hop count. It's just hop count. Accumulated delay variation by all caused by all upstream nodes. This information can be gathered from a packet itself, fib entry, policy entry, etc. Second, put the packet in the specific deadline queue. The allowable scheduling delay queue equals to the planned deadline plus the accumulated delay variation minus the forwarding delay internode. Then the packet will put to the deadline queue with TDL attribute consistent with the value of queue. The following figure shows a simple example. So I will go next. So that is about the traffic regulation and shaping. Traffic regulation and UNI port to ensure that the result bandwidth of service is not exceeded. If there are source the result bandwidth of the data queue, that the intermediate aggregate node should meet multiple M0 less or equal to the MX. For simplicity, MX may equal to the port bandwidth. It does not necessarily consume the whole port bandwidth due to admission control and wall ingress. Traffic shaping is an NNI port to distribute packets into the data queue. The following figure shows 6 parts from the same deterministic service are received on the UNI port, assuming that they arrive at the outgoing port one by one after internode delay. Forwarding delay F, each part will enter the queue with TDL value consistent with the allowable scheduling delay queue of the packet at its current time. So next. This page is about the benefits of this specific solution. For the cost, the time synchronization is not.
Please
go ahead.
Please try to wrap up.
Okay. For the cost, the time synchronization is not required between the network nodes operate based on relative time. Deployment packet multiplexing base is an enhancement of peak scheduling algorithm friendly to upgrade. Each node can independently set the authorization time of the data queues based on self-port bandwidth, support partial upgrade. Scalability. A single set of data queues support multiple levels of residence time. Performance, good jitter control, just a single authorization. Okay. So for next hop, we welcome any questions and comments. Thank you.
Yeah, very interesting work. Thank you for bringing it to the working group. It'd be good to see if there's comments on the list. And we're on the last presentation. The remainder of the time is yours, Karen.
Okay, thank you, Lou. This is PCAP extension for Detnet banded latency. In Detnet, it is required to consider the banded latency for path selection to achieve the Detnet queues. First, as per the Detnet controller plane framework, explicit paths should be calculated and established in control plane to guarantee the deterministic transmission. So first, the end-to-end banded latency constraints should be taken into consideration in path computation. And second, as per the Detnet banded latency, the end-to-end delay bands can be presented as the sum of long queuing delay and the queuing delay along the path. So the queuing mechanisms and the parameters should be determined during path computation. So this draft described the extensions to PCAP to carry banded latency constraints and distribute deterministic paths for end-to-end path computation in Detnet surface. So we propose some PCAP extensions. First is the metric object. We propose two new types of metric object. First is the end-to-end banded latency. The PCC indicate carry the end-to-end banded latency metric to indicate the end-to-end bandit latency constraint in path computation. The end-to-end bandit jitter is the same with the bandit latency. Second, we also proposed the ISP and extended flag TLV. We proposed B bit to indicate the deterministic path capability. Finally, we propose to extend the ERO and the SRERO to distribute the path computation. We propose the queuing information structure. For example, we propose the Detnet sub-TLV and the cycle sub-TLV for different queuing mechanisms. So last step, we hope the lecture to determine this work could be done in Detnet or PCWG. Comments and suggestions are very welcome. Thank you, Lu.
Thank you for this. I would suggest bringing it to PCE as well, and it's likely that they're going to ask for this working group to agree that it's good work, and then once there's general agreement that by the working group here that there's interest in it, we can coordinate with the PCE chairs as to which working group does the actual work. But thank you. You know, this is new work, and it clearly needs to be discussed by the working group to decide if it's something that the group is interested in. So thank you. We're just now at time, so apologize to those at the end who got squeezed on time, and appreciate you shortening things up. And this takes us to the end of the session, and really look forward to seeing everyone hopefully in person in Philadelphia at the next IETF. Janos, anything else?
No, nothing else. You said all. Thank you, everybody, for the contributions.
Absolutely. And also thank you, Luis, for helping us out in the room.